June 6, 1944. Celebes Sea, Southwest Pacific. The tropical darkness pressed against the steel hull of USS Harder like a living thing. At 180 feet beneath the surface, the submarine moved through black water with the silence of a predator stalking prey. Inside the narrow corridors that reeked of diesel fuel, battery acid, and the metallic tang of recycled air, 79 men held their breath and listened to death approaching on the surface above. Commander Samuel David Dealey stood motionless in the conning tower, his weathered hands resting on the periscope housing. At 36 years of age, this quiet Texan had already earned a reputation as one of the most aggressive submarine commanders in the Pacific. His grey eyes, calm as winter steel, focused on the sonar operator's tense face. Every ping, every metallic echo filtering through the hydrophones could signal the end of everything they knew. The water temperature registered 78 degrees Fahrenheit, perfect for sound transmission, perfect for hunting, perfect for dying. Above them, the Imperial Japanese Navy moved with the confidence of an empire that had controlled these waters for 30 months. Their destroyers cut through the tropical swells at 18 knots, their crews scanning the horizon for American aircraft, never imagining that death stalked them from below. In the wardrooms of those steel warships, Japanese officers shared tea and spoke dismissively of American submarine tactics, crude, predictable, lacking the spiritual discipline necessary for true naval warfare. They were about to learn otherwise. The engineering marvel beneath the waves. The USS Harder represented the pinnacle of American submarine engineering in 1944. A Gato-class vessel stretching 311 feet from bow to stern, she displaced 1,500 tons on the surface and could dive to a crushing depth of 300 feet. Her 4 Fairbanks Morse diesel engines generated 5,400 horsepower, propelling her at 21 knots on the surface. Submerged, her electric motors whispered her through the depths at 9 knots for 48 hours without surfacing. 24 Mark 14 torpedoes filled her forward and aft torpedo room. Each weapon measured 21 inches in diameter, stretched 20 feet in length, and carried 643 pounds of Torpex explosive. The Mark 14 had earned a notorious reputation for premature detonations, magnetic exploder failure, and circular runs that sometimes threatened the launching submarine. Yet in the hands of skilled torpedo men like those aboard Harder, these weapons had sunk over 4 million tons of Japanese shipping since Pearl Harbor. The submarine's Kleinschmidt distillation unit converted seawater into drinking water. Her air purification system recycled the atmosphere that kept 79 men alive in a steel tube beneath crushing oceanic pressure. Radio equipment allowed communication with Pearl Harbor across thousands of miles of Pacific Ocean. Radar provided surface detection capabilities that would have seemed miraculous just 5 years earlier. But all this sophisticated military engineering served one fundamental purpose: to place Commander Dealey and his crew in position to sink enemy vessels before those vessels could sink them. The strategic situation in June 1944 demanded such aggressive action. American forces had landed on Saipan 3 days earlier, threatening the inner defensive perimeter of the Japanese Empire. Every Japanese destroyer, cruiser, and battleship that could reach the Mariana Islands might tip the balance against American amphibious forces fighting for their lives on contested beaches. Intelligence reports indicated substantial Japanese naval reinforcements moving north from bases in the Netherlands East Indies. Harder's mission order, transmitted from Admiral Charles Lockwood's headquarters Pearl Harbor, reflected this strategic urgency. Intercept and destroy enemy naval units proceeding north from Borneo toward the battle zone. Operate independently. Use maximum aggression. The survival of American Marines on Saipan might depend on preventing Japanese naval reinforcements from reaching the battle area. First blood in hostile waters. At 3:47 hours on June 21st, sonar operator John Thornton detected propeller sounds bearing 040 degrees. Heavy screws, high speed, approaching from the northeast. Dealey moved to the periscope with the fluid motion of a man who had performed this ritual dozens of times in hostile waters. Through the lens, dawn revealed a sight that quickened every submariner's pulse. A Japanese destroyer, sleek and deadly, cutting through moderate swells at 17 knots. Her rising sun battle flag streamed from the mainmast. Gun crews manned the 5-inch weapons, fore and aft. This was Minazuki, a Mutsuki-class destroyer completed in 1926, displacing 1,300 tons and carrying a crew of 148 men. Japanese destroyers had earned respect throughout the Pacific for their speed, maneuverability, and aggressive tactic. These vessels served as the backbone of Imperial Navy escort forces, protecting convoys, hunting submarines, and screening capital ships from torpedo attack. Their experienced crews had fought in every major naval engagement from Pearl Harbor to the Solomon Islands. Dealey calculated firing angles with mechanical precision. Range, 2,000 yards. Target angle on the bow, port 30 degrees. Speed, 17 knots. The destroyer's course would bring her within optimal torpedo range in 12 minutes. "Make ready tubes 1 and 2, he ordered quietly. The torpedo room crew responded with practiced efficiency. Compressed air hissed through the firing system. Gyroscopes spun to life. The Mark 14 torpedoes armed themselves for combat, their warheads primed to detonate on contact with enemy steel. At 0359 hours, Dealey fired both weapons from a depth of 65 feet. The first torpedo suffered an immediate gyroscope failure, veering 30 degrees to starboard and disappearing into empty. The second weapon maintained course for 40 seconds before its magnetic exploder triggered prematurely, sending a column of water skyward 300 yards short of the target. Minazuki's lookouts spotted both explosions immediately. The destroyer's captain ordered flank speed and commenced a radical zigzag pattern designed to confuse submarine fire control. Battle stations sounded throughout the Japanese vessel as her crew prepared to hunt their underwater attacker. Within minutes, the distinctive ping of enemy sonar echoed through Harder's hull. Japanese sound detection equipment, crude by American standards but effective at close range, had found its prey. The destroyer's screws thrashed the water above as she maneuvered for a depth charge attack. "Take her down to 250 feet, Dealey commanded. "Rig for silent running." Every unnecessary system aboard the submarine shut down. Ventilation fans stopped. Electric motors switched to minimum power. Men moved like ghosts through compartments lit only by red battle lamps. The slightest noise might betray their position to Japanese hydrophone operators, listening for the sounds that would guide their depth charges to target. At 04:02 hours, the first pattern of depth charges exploded around Harder's hull. Pressure and precision under attack. The ocean erupted in violence as 18 depth charges detonated in a coordinated pattern, designed to crush the submarine's pressure hull. Each weapon contained 600 pounds of TNT, timed to explode at predetermined depths, calculated to bracket a submerged target. Shockwaves hammered through the water at 1,500 meters per second, rattling every fitting aboard the American submarine. Light bulbs shattered, gauge faces cracked. The hull groaned under stress that tested every rivet, every welded seam, every structural member that stood between 79 men and crushing death. Paint chips fell like snow in compartments, where men gripped stanchions and tried not to think about the millions of tons of seawater pressing against their steel sanctuary. In the forward torpedo room, torpedoman First Class Robert Rector watched his instruments with professional calm. Depth charges had damaged hundreds of American submarines since 1941, but few were lost to depth charging alone. The Japanese typically dropped their weapons too shallow or too deep, too far ahead or too far behind. Patience and silence offered better survival odds than panic and premature movement. Dealey understood this mathematics of underwater warfare. For 47 minutes, he held Harder motionless at maximum safe depth, while Minazuki's crew searched the area above. Sonar pings echoed through the darkness. The destroyer's screws created a continuous background noise that masked the submarine's movement. Japanese hydrophone operators strained to detect the subtle sounds that would reveal their quarry's position. At 0459 hours, the enemy search pattern moved 2,000 yards to the southeast. Dealey ordered a careful ascent to periscope depth, moving his vessel with the stealth of a hunter who had learned from his mistakes. The destroyer remained visible through the periscope lens, her crew still searching for wreckage that would confirm their kill. They found none. The American submarine had survived her first encounter with Japanese anti-submarine warfare, but 60% of her forward torpedoes had been expended without achieving a single hit. Standard doctrine called for withdrawal to reload and reassess. Dealey chose a different path. "Bring her to 60 feet, he ordered. "Make ready tubes 3 and 4. Executive Officer Guy Gugliotta studied his commanding officer's face with concern. Attacking the same destroyer that had just depth-charged them violated every principle of submarine warfare taught at the Naval War College. The enemy remained alert, his crew at battle stations, his sonar equipment actively searching. Logic demanded evasion and escape. Dealey ignored logic. He had studied Japanese destroyer tactics throughout 3 previous war patrols. Their captains typically conducted search patterns for 2 hours after a depth charge attack. then resumed their original course at reduced speed. This predictability created opportunities for submarine commanders bold enough to exploit them. At 05:27 hours, as morning sunlight penetrated the tropical waters of the Celebes Sea, USS Harder fired 2 more torpedoes at the Japanese destroyer Minazuki. The art of underwater warfare. Both Mark 14 torpedoes ran true to their target. The first weapon struck Minazuki amidships, penetrating her hull below the waterline and detonating in the forward engine room. The massive explosion sent a geyser of steam, debris, and burning fuel oil skyward. Emergency klaxons wailed across the destroyer as her crew fought to contain catastrophic flooding. The second torpedo struck her stern 15 seconds later, destroying the aft magazine and breaking the vessel's back. Minazuki lifted her bow toward the sky like a dying whale, then slid beneath the surface in less than 4 minutes. 28 Japanese sailors survived the sinking, clinging to debris in water stained with fuel oil and human blood. Dealey allowed himself 30 seconds to observe the destruction through his periscope, then ordered Harder into the depth. Other enemy vessels would respond to Minazuki's final radio transmission. The submarine needed distance and concealment before Japanese reinforcements arrived to hunt her crew to extinction. But the Texan had no intention of leaving the area. Intelligence reports indicated regular destroyer patrols along this shipping route. Each enemy vessel sunk here could not escort convoys carrying reinforcements toward the battle for Saipan. Mathematics and moral obligation demanded continued action. For 18 hours, Harder remained submerged in water, barely deep enough to conceal her hull. The crew maintained silent routine, speaking only in whispers, moving through compartments with careful precision. Air grew thick and stale. Carbon dioxide levels rose toward dangerous concentration. Men dozed at their duty stations, conserving oxygen while remaining ready for instant action. At 23:41 hours on June 21st, the submarine's sound detection equipment registered multiple contacts approaching from the north. Through his periscope, Dealey identified 3 Japanese destroyers in line formation, probably searching for survivors from the morning engagement. Their captains had learned caution. They approached at high speed with radical course changes, making torpedo fire control calculations nearly impossible, but not impossible. The lead destroyer was Hayanami, a modern Yugamo-class vessel completed in 1943. She displaced 2,400 tons, mounted 6 5-inch guns, and carried a crew of 228 men. Her captain, Commander Higashi Maru, had survived 18 months of combat in the Solomon Islands. He understood American submarine capabilities and respected their lethality. Behind Hayanami steamed Tanikaze, another Yugamo-class destroyer, and Urakaze, a Kagero-class vessel launched in 1940. Together, these 3 warships represented formidable anti-submarine capability. Their combined sonar equipment could locate submerged targets at ranges exceeding 3,000 yards. Their depth charge armament could saturate vast areas of ocean with explosive destruction. Dealey studied their movements through his periscope with the patience of a chess master, analyzing his opponent's next move. The destroyers maintained course 270 degrees, speed 22 knots, search formation with 800-yard interval. Their predictable pattern would bring the lead vessel within torpedo range in 17 minutes. "Make ready tubes 1, 2, 3, and 4, he ordered quietly. Precision engineering meets combat leadership. The reload process aboard an American submarine represented a masterpiece of mechanical engineering and human coordination. Each Mark 14 torpedo weighed 3,200 pounds, requiring precise handling by teams of specialists working in spaces barely wide enough for 2 men to pass. Overhead, hoists lifted the weapons from storage racks. Torpedo dollies moved them along narrow deck plates toward the firing tube. Torpedo man Robert Rector supervised the loading seek with practiced expertise. Each weapon required inspection of its guidance system, arming mechanism, and propulsion unit. Compressed air levels needed verification. Gyroscope settings had to match fire control calculations transmitted from the conning tower. A single error could result in a premature explosion that would destroy the submarine and everyone aboard. In the conning tower, Lieutenant Guy Gugliotta operated the torpedo data computer, a mechanical calculating device that translated target course, speed, and bearing into firing solution. This analog computer, primitive by later standards but revolutionary for 1940, allowed submarine commanders to calculate intercept courses automatically, rather than relying solely on intuition and experience. The TDC required constant updating as target parameters changed. Range input came from periscope observations and sound bearing. Target course and speed required careful estimation based on visual analysis of bow wave patterns and wake characteristics. Operator error could send torpedoes hundreds of yards wide of their intended targets. Dealey had mastered these calculations through 3 previous war patrols and thousands of hours of training exercises. His ability to estimate range, course, and speed from brief periscope observations had become legendary throughout the Pacific submarine force. Other commanders sought his advice on torpedo fire control techniques. His previous patrols had resulted in confirmed sinkings totaling over 40,000 tons of Japanese shipping. At Dourojin 18 hours on June 22nd, with Hayanami approaching optimal firing range, Dealey made his final observations through the periscope. The destroyer maintained course and speed with mechanical precision, her lookouts scanning the horizon for surface contact while trusting their sonar to detect submerged threats. They trusted incorrectly. "Fire 1!" Dealey ordered. The compressed air system expelled the first torpedo from its tube, with a distinctive whoosh that experienced submariners could hear throughout the boat. High-pressure air bubbled toward the surface, potentially revealing the submarine's position to alert enemy lookouts. Speed and accuracy now mattered more than concealment. Fire 2, Fire 3, Fire 4, 4, Mark 14. Torpedoes raced through the dark Pacific waters toward their target, their electric motors driving them at 46 knots along carefully calculated intercept courses. Each weapon carried the hopes of 79 American sailors and the accumulated expertise of the most advanced submarine force in maritime history. Mathematical precision meets Japanese steel. The first torpedo struck Hayanami at frame 67, penetrating her hull 3 feet below the waterline and detonating in the forward boiler room. The explosion killed 18 men instantly and flooded 2 compartments with superheated steam. Emergency damage control parties rushed to contain the flooding, while the destroyer's captain ordered maximum speed toward shallow water. The second weapon missed by 30 yards, its wake clearly visible to Japanese lookouts, who now understood their mortal danger. Battle stations sounded throughout all 3 destroyers as their crews prepared for anti-submarine warfare. Depth charge crews armed their weapons, while sonar operators searched frantically for the attacking submarine's position. The third torpedo struck Hayanami amidships, breaking her keel and opening a hole large enough to drive a truck through. The destroyer's back broke with a sound like thunder. Her forward section lifted toward the sky while her stern settled into the ocean. Within 3 minutes, she had vanished beneath the surface, taking 137 men with her. The fourth torpedo continued toward Tanikaze, but her captain had ordered emergency maneuvers that brought his vessel clear of the weapon's path. The Mark 14 exploded harmlessly against a coral reef 2,000 yards beyond its intended target. 2 destroyers remained, their crews now fully alert to the submarine threat lurking in waters they had considered secure. Both vessels commenced systematic depth charge attacks while maintaining communications with shore-based aircraft that would arrive at dawn to join the hunt. Dealey ordered harder to maximum depth and silence. The submarine settled toward the ocean floor like a wounded shark seeking darkness and concealment. Above, the surviving Japanese destroyers began the methodical search pattern that might locate and destroy their underwater adversary. For the next 6 hours, USS Harder played a deadly game of hide-and-seek with enemy forces that possessed every technical advantage except surprise. Japanese destroyers could steam at 30 knots on the surface while the American submarine crawled through the depths at 3 knots. Enemy vessels carried enough depth charges to saturate vast areas of ocean with explosive destruction. Their sonar equipment, though primitive, could detect submerged targets under favorable conditions. But the Japanese faced one insurmountable disadvantage. They were hunting Samuel Dealey, a submarine commander who understood their tactical doctrine better than most of their own captains understood it. The psychology of underwater combat. Inside the submarine, men counted seconds between depth charge explosions and calculated their distance from certain death. The human mind, evolved for survival on dry land under blue skies, struggled to comprehend existence in a steel container beneath millions of tons of crushing water. Training and discipline provided the only barriers between rational thought and paralyzing terror. Signalman Third Class James Smith, 19 years old and 6 months removed from basic training in Connecticut, wrote in his diary during quiet moments between enemy attacks. His words, preserved in the National Archives, provide insight into the psychological reality of submarine warfare. We are hunters and hunted, predators and prey, living in a world where silence means survival and noise means death. Every man aboard knows that our next breath depends on the skill of our commanding officer and the reliability of machinery built by workers we will never meet. The machinery Smith referenced represented the pinnacle of American industrial engineering in 1940. Electric motors manufactured by General Electric in Schenectady, New York. Periscopes crafted by Kollmorgen Optical Corporation using precision lenses ground to tolerances measured in thousandths of an inch. Sonar equipment developed by Bell Telephone Laboratories and refined through combat experience, purchased with American lives. Each component had been designed, tested, and mass-produced by an industrial system geared towards scientific warfare. American factories operated 24 hours per day, producing the tools that enabled commanders like Dealey to hunt enemy vessels in waters 8,000 miles from the continental United States. This integration of industrial capacity, technological innovation, and tactical expertise represented a new form of warfare that would reshape naval combat forever. But technology remained subordinate to human decision-making. In the cramped conning tower of USS Harder, Commander Dealey faced choices that would determine whether 79 Americans lived or died in the next few hours. Standard submarine doctrine recommended evasion after a successful attack, retreat to safer waters, reload torpedoes, transmit contact reports to higher headquarters, and await new orders. Dealey chose defiance over doctrine. At 14:30 hours on June 22nd, with enemy destroyers still searching the area, he ordered his submarine to periscope depth for observation of surface conditions. Through the lens, he observed Tanikaze and Urakaze maintaining systematic search patterns, while aircraft from Balikpapan airfield provided aerial reconnaissance. The Japanese had committed substantial resources to hunting one American submarine, which meant those resources could not be used elsewhere. Every Japanese destroyer hunting USS Harder could not escort convoys carrying reinforcements toward the battle for Saipan. Every aircraft searching these waters could not attack American amphibious forces struggling to establish themselves on contested beaches. The submarine's mere presence had achieved strategic significance beyond the tactical value of ships sunk. This mathematical reality drove Dealey's next decision. Rather than evade the enemy search, he would eliminate the searchers. Industrial innovation versus imperial tradition. The contrast between American and Japanese naval philosophy became apparent during the next phase of the engagement. American submarine doctrine emphasized technological solutions to tactical problems. Fire control computers calculated intercept courses. Sonar equipment provided precise range and bearing data. Radar systems detected surface contacts beyond visual range. The submarine itself represented a platform for delivering advanced weapons with scientific precision. Japanese destroyer tactics relied heavily on traditional naval concepts adapted from surface warfare. Individual ship commanders exercised broad tactical discretion. Crew training emphasized spiritual preparation and physical courage over technical expertise. Communications between vessels used flag signal and voice radio rather than encrypted data link. The Imperial Navy valued Bushido spirit over mechanical calculation. Both philosophies had achieved notable successes during the Pacific. Japanese destroyers had dominated night surface actions in the Solomon Islands through aggressive tactics and superior torpedo technology. American submarines had strangled Japanese merchant shipping through systematic campaigns that destroyed enemy logistics capability. The encounter between USS Harder and her pursuers would test which approach proved superior in underwater combat. At 1847 hours, as tropical darkness settled over the Celebes Sea, Dealey made his move. Tanikaze had separated from her companion to investigate a suspicious sonar contact 3,000 yards to the northwest. This left Urakaze alone, steaming at moderate speed while her crew conducted methodical depth charge attacks against suspected submarine positions. The Japanese destroyer's predictable search pattern created the opportunity Dealey had waited for throughout the afternoon. From a depth of 90 feet, USS Harder maneuvered into attack position with the stealth of a mechanical shark. Her electric motors produced no detectable noise signature. Her streamlined hull moved through the water without creating visible disturbance on the surface. At 1852 hours, with Urakaze approaching optimal firing range, Dealey ordered the attack sequence that would demonstrate American engineering superiority over Japanese tactical doctrine. Make ready tubes 1 and 2, set depth 6 feet, spread 1 degree right and left. The torpedo room crew responded with automatic precision. Each Mark 14 torpedo represented 18 months of development by the Naval Torpedo Station at Newport, Rhode Island. Magnetic influence exploders designed to detonate beneath enemy hulls rather than on contact, had been refined through combat experience and technical analysis. Gyroscopic guidance systems maintained precise course control despite ocean currents and pressure variations. These weapons embodied the American approach to warfare: scientific analysis of combat problem, engineering solutions implemented through industrial mass production, continuous improvement based on operational experience. The Mark 14 torpedo of June 1944 bore little resemblance to the failure-prone weapons that had frustrated submarine commanders in 1942. At the heart of this technological evolution lay a fundamental truth about American military capability. The nation that had built transcontinental railroads, mass automobile production, and continental telecommunications systems possessed the industrial infrastructure necessary to outproduce any enemy. German submarines might achieve tactical superiority through individual crew expertise. Japanese destroyers might demonstrate superior night fighting techniques. But American industrial capacity would eventually overwhelm both adversaries through sheer volume of advanced weapons delivered to competent operators. Commander Dealey represented the human element in this equation. His tactical decisions would determine whether American industrial superiority translated into combat victory in the waters off Borneo. The moment of truth approaches. Through his periscope, Dealey observed Urakazi approaching from bearing 090 degrees, her bow cutting through moderate swells at 14 knots. The destroyer's captain maintained a steady course, apparently confident that his depth charge attacks had eliminated the submarine threat. Japanese lookouts scanned the horizon through binoculars, while their radar operator searched for aircraft contact that might indicate American air support. They detected neither the periscope cutting a thin wake 200 yards to starboard, nor the torpedo tubes trained on their vessel with mathematical precision. The range closed steadily. 1,500 yards, 1,200, 1,000. At 800 yards, optimal firing range for a stationary target steaming on a predictable course, Dealey prepared to demonstrate the lethal efficiency of American submarine warfare. Bearing mark, range mark, angle on the bow, port 15 degrees, down periscope. Lieutenant Gugliotta translated these observations into firing data through his torpedo data computer. Target course 090 degrees, speed 14 knots, range 800 yards, and closing. The mechanical calculator determined intercept angles automatically, eliminating human error from fire control calculations. In the forward torpedo room, Torpedoman Rector verified final weapon setting. Both Mark 14 torpedoes armed and ready for launch. Compressed air pressure normal. Gyroscopes spinning at operational speed. Each weapon carried sufficient explosive power to break a destroyer's keel if properly placed. The mathematics of destruction reduced to simple geometry. Two intersecting courses in three-dimensional space. Time and distance calculations that would determine whether 79 Americans survived the next 10 minutes or joined the thousands of submariners who had already died in Pacific waters. Dealey raised his periscope for final observations. Urakazi maintained course and speed with mechanical predictability. Her crew remained at battle station but showed no awareness of their imminent death. Japanese naval discipline had produced a destroyer that functioned like clockwork, steaming to its destruction with perfect military precision. At 1856 hours, Commander Samuel David Dealey spoke two words that would echo through naval history. Fire 1. Precision engineering meets enemy steel. The first Mark 14 torpedo exploded from its tube with compressed air pressure sufficient to launch a 2-ton projectile at 46 knots. Bubbles raced toward the surface as the weapon began its deadly journey through tropical waters that had witnessed 3 years of naval combat. Behind it, the second torpedo followed 15 seconds later, both weapons programmed to converge on the same target from slightly different angles. Japanese lookouts aboard Urakazi spotted the first torpedo wake when it reached the halfway point between submarine and target. Battle stations sounded throughout the destroyer as her captain ordered emergency maneuvers designed to evade the incoming weapon. The vessel's rudder swung hard to starboard while her engines increased to flank speed, creating a massive bow wave that announced her desperation to every ship within visual range. Too late. The first torpedo struck Urakazi forward of the bridge, penetrating her hull below the waterline and detonating in the communications center. The explosion killed 12 men instantly and severed electrical connections to half the destroyer's combat system. Seawater flooded through a hole large enough for 3 men to walk through side by side. The second weapon struck amidships 18 seconds later. breaking the destroyer's back and opening her hull to the ocean. Urakaze lifted her bow toward the tropical sky, paused for a moment that seemed to last forever, then slid stern first beneath the surface. Her death took less than 4 minutes from the moment of the first torpedo impact. 118 Japanese sailors died with their ship. 27 survivors clung to debris in water contaminated with fuel oil and human remains. They would drift for 36 hours before rescue vessels located them, and only 13 would survive their ordeal in the tropical sun. But USS Harda's hunting was far from over. Strategic implications of tactical success. The sinking of 2 Japanese destroyers within 24 hours sent shockwaves through Imperial Navy headquarters in Tokyo. These vessels represented substantial investments in steel, machinery, and trained personnel that Japan could not easily replace. More importantly, their loss indicated that American submarines had achieved tactical superiority in waters previously considered secure by Japanese planners. Admiral Soemu Toyoda, Commander-in-Chief of the Combined Fleet, received reports of the attacks with mounting concern. Each destroyer sunk in the Netherlands East Indies could not escort convoys carrying oil from Borneo to Japanese refineries. Each escort vessel destroyed reduced the Imperial Navy's ability to protect merchant shipping that sustained Japan's war economy. The mathematics of attrition favored American industrial capacity over Japanese resource limitations, but Toyoda faced a more immediate problem. Intelligence reports indicated that the submarine responsible for these attacks remained in the area, apparently hunting additional targets, rather than withdrawing to safer waters. Standard American submarine doctrine called for evasion after successful attacks, yet this commander seemed determined to continue operations despite overwhelming enemy response. The admiral ordered additional anti-submarine assets to the Celebes Sea. 4 destroyers from Balikpapan received orders to hunt the American submarine with priority over all other missions. Long-range aircraft from bases throughout the Netherlands East Indies would provide continuous aerial reconnaissance. The Imperial Navy committed resources valued at over $50 million to eliminate 1 American submarine and her crew. This response validated Commander Dealey's tactical decision to remain in contested waters. Every Japanese asset hunting USS Harda could not be used against American amphibious forces fighting for survival on Saipan. The submarine had become a strategic magnet, drawing enemy resources away from the primary battle area through simple aggressive action. At 0630 hours on June 23rd, Harda's sonar detected multiple contacts approaching from the northeast. 4 Japanese destroyers in line formation, steaming at 25 knots directly toward the submarine's position. Their intent was unmistakable. They had come to avenge their fallen comrades and eliminate the underwater threat that had disrupted Japanese naval operations throughout the Celebes Sea. Dealey studied the approaching force through his periscope with professional interest. The lead destroyer was a Sashimo, a modern Yugumo-class vessel commissioned in 1943 and armed with the latest Japanese anti-submarine weapon. Behind her steamed Michishio, Yamagumo, and Minagumo, representing the core strength of Japanese destroyer forces in the Southwest Pacific. These 4 vessels carried nearly 1,000 sailors, mounted 24 5-inch guns, and operated sophisticated sonar equipment capable of detecting submerged submarines at extended ranges. Their combined firepower could saturate vast areas of ocean with depth charges, while their speed advantage allowed them to maintain contact with any submarine attempting to escape. Against this overwhelming force, USS Harda possessed 2 advantages: concealment and the tactical genius of her commanding officer. The hunter becomes the hunted. Standard submarine doctrine faced its ultimate test as 4 enemy destroyers approached optimal depth charge range. Every textbook recommended immediate evasion to maximum depth, followed by silent running until the enemy search moved elsewhere. Dealey had read the same textbooks and understood their logic. Survival required retreat. He chose attack instead. The 4 destroyers maintained formation discipline as they approached the submarine's last known position. A Sashimo led the column at 25 knots, her sonar sweeping methodically for contacts that would guide the coordinated attack. Behind her, the other vessels prepared depth charge patterns designed to saturate a mile-square area with explosive destruction. Japanese naval doctrine emphasized overwhelming firepower applied with mathematical precision. Each destroyer carried 96 depth charges, set to detonate at predetermined intervals and depths. Properly coordinated, their combined attack could create an underwater earthquake that would crush any submarine caught within the impact zone. But coordination required predictability. Formation discipline demanded that each vessel maintain course and speed according to predetermined patterns. The same tactical rigidity that made Japanese destroyer attacks so effective also made them vulnerable to submarine commanders bold enough to exploit their weaknesses. Dealey understood these weaknesses better than most Japanese captains understood their own tactical doctrine. 3 previous war patrols had taught him to think like his enemies, to anticipate their responses, and to position his submarine where mathematics and psychology intersected in his favor. At 0647 hours, he made a decision that defied every principle of submarine warfare taught at the Naval War College. USS Harder surfaced to attack position. The submarine's hull broke through moderate swells with an explosion of spray and compressed air as her ballast tanks expelled thousands of gallons of seawater. Her conning tower emerged into tropical sunlight, followed by her deck gun mount and forward torpedo room hatch. Within 90 seconds, she rode on the surface like a steel whale, challenging the entire Imperial Japanese Navy to single combat. Japanese lookouts spotted the American submarine immediately. Battle stations sounded throughout all 4 destroyers as their captains realized they faced an opponent who had abandoned every defensive advantage in favor of maximum offensive capability. On the surface, USS Harder could employ her full complement of torpedo tubes while using her radar to coordinate attacks against multiple targets. The tactical situation had shifted dramatically. 4 hunters had become 4 targets. Surface action in hostile waters. The range between the submarine and the leading destroyer closed at a combined speed of 46 knots. Sashimo's captain ordered his guns to engage the surface submarine while maintaining course toward ramming position. 5-inch shells began splashing around USS Harder as Japanese gunners adjusted their aim against a target that presented a minimal silhouette from their angle of approach. Dealey ignored the incoming fire with the professional calm that had earned him legendary status among Pacific submarine commanders. At 2,000 yards range, enemy shells posed less immediate danger than the depth charges that would rain down if his submarine remained submerged. Surface action offered his only realistic chance of defeating 4 destroyers simultaneously. "Make ready all tubes forward," he ordered. "Set depth 4 feet. Spread 2 degrees right and left." The torpedo room crew responded with automatic precision despite enemy shells exploding progressively closer to their target. Each Mark 14 torpedo represented their only defense against overwhelming Japanese firepower. Mechanical reliability and human skill would determine whether they lived to see another sunset or joined the hundreds of American submariners already resting on Pacific Ocean floors. At 200 yards range, Dealey commenced his attack against impossible odds. Fire 1, Fire 2, Fire 3, Fire 4. 4 torpedoes raced through tropical waters toward the leading Japanese destroyer, while enemy shells continued to bracket their launcher with increasing accuracy. The mathematics of surface combat favored the destroyer's superior speed and firepower, but torpedo warfare followed different equations. A single hit could eliminate any target regardless of size differential. Aboard a Sashimo, Japanese lookouts tracked the incoming torpedo wakes with professional interest and growing alarm. 4 weapons approaching on slightly different bearings, their combined spread designed to ensure hits, even if the target maneuvered radically. The destroyer's captain ordered emergency turns while his crew prepared for impact that seemed mathematically inevitable. The first torpedo passed 50 yards ahead of a Sashimo's bow, its wake clearly visible to the entire Japanese crew. The second weapon passed 30 yards astern, close enough that men on deck could smell the distinctive odor of torpedo fuel. The third torpedo struck the destroyer amidships with an explosion that lifted her entire forward section out of the water. The fourth weapon continued toward Michishio, striking her forward magazine and detonating with sufficient force to break the vessel's keel. Both destroyers began settling by the bow as their crews fought to contain catastrophic flooding and maintain some semblance of combat capability. But 2 destroyers remained, their captains now fully committed to destroying the American submarine before she could submerge and escape. The tactical initiative had shifted again. USS Harder faced concentrated attack from enemies who understood they were fighting for their lives. Chafimwa 3, decision point, under fire. With 2 destroyers sinking and 2 more approaching at flank speed, Commander Dealey faced the critical decision that would determine his crew's survival. Standard doctrine demanded immediate submergence to evade enemy gunfire and depth charges. Every second on the surface increased their vulnerability to Japanese weapons that could crush a submarine's hull with a single direct hit. but submerging would limit his submarine to 4 remaining torpedoes in the aft tubes, insufficient firepower to engage 2 undamaged destroyers while allowing them to coordinate systematic depth charge attacks. Mathematics suggested that USS Harder's only hope lay in maintaining surface action despite overwhelming Japanese advantages. Dealey chose to fight. "All back emergency," he ordered. "Make ready tubes 7 and 8. The submarine's electric motors reversed direction, slowing her forward momentum while creating optimal firing angles for the aft torpedo tube. Japanese shells continued to splash around the narrow target as enemy gunners adjusted their aim with mechanical precision. One direct hit would end the engagement instantly. Yamagumo approached from bearing 045 degrees, her 5-inch guns blazing while her crew prepared for ramming action if torpedo attack proved insufficient. Behind her, Minagumo maneuvered to prevent the American submarine from escaping toward deeper water. The tactical trap was closing with lethal efficiency. At 800 yards range, Dealey fired his final 2 torpedoes. Both weapons ran true to their target. Yamagumo's captain attempted evasive maneuvers, but his destroyer's momentum carried her directly into the torpedo paths. The first weapon struck her forward engine room, flooding 2 compartments while killing 23 men instantly. The second torpedo detonated against her stern, destroying the steering gear and leaving the vessel dead in the water. 4 Japanese destroyers had been reduced to floating wreckage within 18 minutes of surface combat. The mathematics of naval warfare had been rewritten by one American submarine commander who refused to accept defensive tactics against superior numbers. But the engagement was far from over. Minagumo remained combat effective, and her captain possessed both the firepower and determination necessary to sink USS Harder before additional American submarines could respond to radio distress calls that had not been transmitted. The final gambit. With all torpedo tubes empty and enemy gunfire bracketing her hull with increasing accuracy, USS Harder faced destruction unless her crew could implement one final tactical maneuver. Dealey ordered dive stations, sending his submarine beneath the surface, while Minagumo closed range for the killing blow. The Japanese destroyer's captain understood his advantage. The American submarine had expended all forward torpedoes and possessed insufficient time to reload before depth charges could be delivered with lethal precision. Standard anti-submarine doctrine recommended systematic search patterns that would locate and destroy the underwater target within 2 hours. But Commander Matsuo Yoshida had not anticipated Samuel Dealey's next innovation in submarine warfare tactics. Instead of diving to maximum depth and attempting evasion, USS Harder leveled off at 60 feet and maintained moderate speed toward the Japanese destroyer. This shallow depth provided minimal protection against depth charges while offering one critical advantage. The submarine could surface rapidly for gun action if opportunity presented itself. Yoshida observed the American submarine's dive through his binoculars, then ordered his crew to commence depth charge attacks against the target's probable position. 96 weapons stood ready for deployment, in patterns calculated to saturate wide areas of ocean with explosive destruction. At 07:21 hours, the first pattern of 18 depth charges detonated around USS Harder's hull. The explosion sequence hammered through the submarine's structure with violence that tested every system aboard. Light fixtures shattered, electrical connections sparked, the hull groaned under pressure waves that would have collapsed merchant vessels of equivalent size. In the torpedo room, men clung to stanchions while contemplating the mathematical certainty of their destruction. But the submarine survived. Her damaged hull maintained watertight integrity while her crew assessed system casualties and prepared for the depth charge patterns that would follow. Japanese doctrine called for systematic attacks at 30-minute intervals until sonar contact was lost or debris confirmed target destruction. Dealey had different plans. As Minagumo maneuvered for her second depth charge attack, USS Harder ascended to periscope depth with the silence of a predator that had learned patience through mortal combat. Through his lens, the American commander observed the Japanese destroyer positioning herself for systematic anti-submarine warfare according to tactical doctrine that assumed enemy passivity. The assumption proved fatal. Engineering triumphed through tactical innovation. What followed represented the culmination of American submarine development since Pearl Harbor. Technical innovation, industrial capacity, and combat experience had produced weapon systems capable of defeating superior enemy forces through scientific application of firepower. The Mark 14 torpedo, despite early reliability problems, had evolved into the most effective naval weapon in the Pacific theater. But weapons required operators capable of maximizing their potential. Commander Dealey exemplified the American submarine force that had strangled Japanese merchant shipping through systematic application of advanced technology guided by tactical intelligence. His decisions during the engagement with 4 Japanese destroyers would be studied at naval academies for decades as examples of aggressive leadership overcoming material disadvantage. At 0734 hours, USS Harder fired her final torpedo at point-blank range. The weapon struck Minagumo below her forward gun mount, penetrating the hull and detonating in the forward magazine. The explosion lifted the destroyer's entire bow section 50 feet into the air before it crashed back into the ocean with sufficient force to break the vessel's spine. Within 3 minutes, the last of 4 Japanese destroyers had settled beneath the surface of the Celebes Sea. Total engagement time, 27 minutes. Torpedoes expended, 10. Enemy vessels destroyed, 4. American casualties, none. The mathematics spoke for themselves. Industrial engineering and tactical innovation had achieved victory against odds that should have guaranteed defeat. Japanese naval superiority in the Southwest Pacific had been challenged by one American submarine whose crew refused to accept conventional wisdom about defensive combat. But victory carried its own dangers. Radio transmissions from the sinking destroyers would bring additional Japanese forces to the area within hours. Aircraft from Balikpapan would arrive at dawn to search for the submarine that had disrupted enemy naval operations throughout the Celebes Sea. USS Harder needed distance and concealment before overwhelming response could trap her crew in waters too shallow for effective evasion. Strategic consequences of tactical victory. The destruction of 4 Japanese destroyers in a single engagement represented more than tactical success. These vessels had displaced 9,000 tons of warship tonnage, mounted 24 5-inch guns, and carried nearly 1,000 trained sailors. Their loss eliminated substantial anti-submarine capability from Japanese forces operating in the Netherlands East Indies. More importantly, the engagement demonstrated American submarine superiority in waters previously dominated by the Imperial Navy. Japanese merchant captains would now demand destroyer escorts for every convoy movement between Java and the Philippines. Anti-submarine forces would be concentrated in areas where American submarines operated with increasing efficiency. Resources desperately needed for other operations would be diverted to counter a threat that had achieved strategic significance through aggressive tactical action. Admiral Toyoda received reports of the disaster, with mounting concern for Japan's ability to maintain naval operations in the Southwest Pacific. 4 modern destroyers represented irreplaceable losses for a nation whose shipbuilding capacity had been devastated by American strategic bombing campaigns. Equally serious, the engagement indicated that American submarine commanders had achieved tactical expertise that challenged Japanese naval doctrine at its foundation. The admiral ordered immediate reinforcement of anti-submarine forces throughout the region. 8 additional destroyers would be transferred from the Central Pacific to hunt American submarines operating near Japanese supply routes. Long-range aircraft would maintain continuous patrols over shipping lanes that sustained Japan's war economy. The Imperial Navy would commit resources valued at over $200 million to counter submarine threats that had disrupted carefully planned logistics operations. This response validated every tactical decision Commander Dealey had made during 4 days of continuous combat. By maintaining aggressive action rather than withdrawing after initial success, USS Harder had drawn disproportionate enemy resources away from more significant battles. Japanese destroyers hunting one American submarine could not escort convoys carrying reinforcements toward the battle for Saipan, where American Marines continued fighting for survival on contested beaches. The strategic implications extended beyond immediate tactical consideration. American industrial capacity had produced sufficient submarines to maintain continuous pressure on Japanese shipping throughout the Pacific theater. Each enemy vessel sunk reduced Japan's ability to transport raw materials necessary for continued war production. The mathematics of attrition favored American submarine operations over Japanese defensive capabilities. But individual success stories, like USS Harder's engagement in the Celebes Sea, masked more sobering realities about submarine warfare casualties. For every commander who achieved legendary status through aggressive action, others died in depths where courage could not overcome mechanical failure or superior enemy firepower. The Pacific Ocean had become a graveyard for submariners from both sides, who paid the ultimate price for tactical miscalculations measured in seconds and yards. The price of excellence. Success in submarine warfare required perfect integration of human skill, mechanical reliability, and tactical intelligence. Any failure in this triangle could result in catastrophic loss of irreplaceable assets and highly trained personnel. USS Harda's crew had achieved the ideal balance during their engagement with 4 Japanese destroyers, but maintaining such performance indefinitely challenged the limits of human endurance and mechanical precision. Commander Dealey understood these realities better than most submarine officers in the Pacific Fleet. 3 previous war patrols had taught him that aggressive action produced decisive results, but at costs measured in crew fatigue, equipment wear, and statistical probability. Each engagement increased the mathematical likelihood that mechanical failure or tactical error would end his crew's combat effectiveness permanently. The submarine force had lost 39 vessels since Pearl Harbor, with casualty rates exceeding 20% among crews that volunteered for the most dangerous assignment in naval warfare. These statistics reflected the reality that submarine operations in Japanese-controlled waters required acceptance of mortality, odds that would have been considered unacceptable in other military contexts. Yet volunteers continued to request submarine duty throughout the Pacific theater. The combination of advanced technology, elite crew selection, and aggressive tactical doctrine attracted sailors who preferred skilled combat to routine surface operations. Submarine service offered opportunities for individual excellence that reflected American values of technical innovation and entrepreneurial initiative. Dealey embodied these characteristics while adding tactical genius that transformed routine patrol assignments into strategic victories. His crew's success during the Celebes Sea engagement had demonstrated American submarine capability at their highest level, while establishing benchmarks for future operations throughout the Pacific theater. But even the most successful commanders faced limitations imposed by geography, logistics, and enemy response. USS Harda needed fuel, provisions, and torpedo reloads that could only be provided at Australian bases, 800 miles from their current position. Japanese aircraft would maintain continuous surveillance over waters where 4 destroyers had been sunk by unknown enemy action. The tactical situation demanded immediate withdrawal to friendly territory before overwhelming response could trap the American submarine in shallow waters unsuitable for effective evasion. Dealey ordered course toward Darwin, Australia, while maintaining periscope depth to observe enemy reaction to the morning's destruction. Technical analysis and lessons learned. The engagement between USS Harda and 4 Japanese destroyers provided valuable intelligence about enemy anti-submarine capabilities and tactical doctrine. American submarine commanders throughout the Pacific theater would study detailed reports of the action to improve their own combat effectiveness against similar threats. Japanese destroyer tactics had proven predictable under pressure, with individual captains following standard doctrine rather than adapting to unusual circumstances. This rigidity created opportunities for submarine commanders willing to violate conventional wisdom about defensive combat. Surface action against multiple destroyers, while extremely dangerous, had achieved decisive results through concentration of firepower and aggressive maneuvering. The Mark 14 torpedo had performed reliably throughout the engagement, with 8 hits achieved from 10 weapons fired. This success rate exceeded average performance data for American submarine operations and reflected improvements in weapon reliability achieved through systematic analysis of combat reports and technical modifications. Industrial engineering and battlefield feedback had produced weapon systems capable of achieving decisive tactical results. American submarine construction had proven superior to Japanese anti-submarine weapons in direct combat. USS Harda's hull had survived multiple depth charge attacks while maintaining structural integrity sufficient for continued operations. This durability reflected design standards and manufacturing quality that gave American submarines significant survival advantages over enemy vessels of comparable size. Crew training and leadership had proven decisive factors in achieving tactical success against superior numbers. The integration of technical expertise, combat experience, and aggressive decision-making had enabled 79 men to defeat nearly 1,000 enemy sailors equipped with advanced weapons systems. This human element would continue to determine submarine warfare outcomes throughout the Pacific theater. Intelligence gathering during combat operations had provided valuable data about enemy capabilities, tactics, and responses to American submarine actions. Each engagement contributed to tactical knowledge that improved subsequent operations throughout the submarine force. Scientific analysis of combat results would enhance American submarine effectiveness while reducing casualty rates through improved tactical doctrine. The journey home, USS Harder's transit toward Darwin, required careful navigation through waters that would soon swarm with Japanese search aircraft and surface vessels hunting the submarine responsible for unprecedented destroyer losses. Dealey maintained submerged operations during daylight hours while surfacing after dark to recharge batteries and communicate with higher headquarters. His radio transmission to Admiral Christie's headquarters in Australia contained the understated report that had become characteristic of American submarine operations. 4 destroyers sunk in Celebes Sea, returning to base for refit and reload. The message provided no hint of the dramatic surface action that had achieved these results, or the tactical innovations that had made victory possible against overwhelming odds. Shore-based intelligence analysts would later recognize the strategic significance of USS Harder's patrol results. 4 Japanese destroyers represented substantial combat capability that could no longer escort convoys, hunt American submarines, or support amphibious operations throughout the Southwest Pacific. Their loss forced Japanese commanders to transfer additional anti-submarine assets from other theaters while restricting merchant shipping to heavily defended routes. The mathematical impact extended beyond immediate tactical considerations. Japanese shipbuilding capacity could not replace 4 modern destroyers within 12 months, while American industrial production delivered new submarines to Pearl Harbor monthly schedule. The war of attrition favored American manufacturing capability over Japanese resource limitation, with each enemy vessel sunk by submarine. But personal costs accompanied statistical. USS Harder's crew had operated at maximum stress levels for 96 consecutive hours while facing destruction from multiple enemy forces. Physical exhaustion and psychological pressure had pushed men to limits that challenged human endurance under extreme conditions. Medical personnel at Darwin would need weeks to restore the crew to operational readiness. Equipment maintenance requirements reflected similar pressures on mechanical systems designed for sustained combat operations. Battery capacity had been depleted through continuous submerged operation. Torpedo tubes required cleaning and calibration. Hull integrity needed inspection for damage caused by depth charge attacks. The submarine would require extensive maintenance before returning to combat operations. Recognition and reflection. Admiral Ralph Christie received USS Harder's patrol report with professional satisfaction and growing concern for the strategic implications of Japanese anti-submarine response. 4 destroyer losses would trigger massive enemy reaction that could affect American submarine operations throughout the Southwest. Success carried consequences that extended beyond immediate tactical benefits. The Admiral recommended Commander Dealey for the Medal of Honor, citing extraordinary heroism and tactical excellence that had achieved decisive results against superior enemy forces. Previous submarine commanders had earned America's highest decoration for individual action, but none had sunk 4 major warships in a single engagement while demonstrating tactical innovations that challenged fundamental assumptions about submarine warfare. But recognition could not address the broader strategic questions raised by USS Harder's patrol results. How long could individual submarines maintain such aggressive operations before statistical probability and enemy response overwhelmed even the most skilled crews? What tactical modifications would be required if Japanese anti-submarine forces adapted their doctrine to counter American innovation? These questions would be answered through subsequent combat operations that tested the lessons learned during the Celebes Sea engagement. American submarine commanders throughout the Pacific theater would attempt to replicate Dealey's tactical success while adapting his methods to different enemy forces and geographical conditions. The submarine war would continue with increasing intensity as American industrial capacity produced advanced vessels faster than Japanese anti-submarine forces could develop effective countermeasures. But individual battles like USS Harder's engagement with 4 destroyers represented the human element that transformed manufacturing statistics into strategic victory. The mathematics of naval warfare. Statistical analysis of submarine operations in the Pacific theater revealed patterns that validated aggressive tactical doctrine, exemplified by commanders like Samuel Dealey. American submarines had sunk over 4 million tons of Japanese merchant shipping while destroying hundreds of enemy warships through systematic application of advanced weapons technology guided by tactical intelligence. These achievements reflected integration of industrial capacity, technical innovation, and operational experience that had transformed American submarine forces from pre-war defensive concepts into offensive weapons capable of strategic impact. The transition required abandonment of conservative tactical doctrine in favor of aggressive action that maximized advanced equipment capabilities while accepting increased casualty risks. USS Harder's engagement with 4 Japanese destroyers represented the culmination of this evolutionary process. Technical superiority, tactical innovation, and crew excellence had combined to achieve victory against odds that should have guaranteed defeat. The engagement demonstrated American submarine warfare at its highest level, while establishing benchmarks for future operations throughout the Pacific theater. But success stories like Harder's patrol masked sobering realities about submarine warfare casualty and the mathematical certainty that aggressive tactics would eventually encounter situations where skill and equipment could not overcome enemy advantages. The Pacific Ocean contained numerous examples of American submarine crews who had died attempting to replicate the tactical excellence that had made other commanders legendary. Understanding these realities required acceptance of warfare as a statistical process where individual heroism operated within broader contexts of industrial capacity, strategic objectives, and enemy response capabilities. American submarine commanders could not ignore mathematical constraints that determined operational feasibility regardless of personal courage or tactical skill. The war would be won through systematic application of American advantages rather than individual actions, however spectacular their immediate results. Industrial capacity would eventually overwhelm Japanese defensive capabilities through sheer volume of advanced weapons delivered to competent operators throughout the Pacific theater. Legacy of the Harder. 2 months after her legendary patrol in the Celebes Sea, USS Harder would meet her fate in the waters off Luzon, struck by depth charges from a Japanese escort that had learned to counter American submarine tactics through bitter experience. Commander Dealey and his entire crew would joining the thousands of submariners who had paid the ultimate price for American victory in the Pacific. But the tactical lessons learned during their encounter with 4 Japanese destroyers would survive to influence submarine warfare doctrine for decades. Naval academies would study the engagement as an example of aggressive leadership, overcoming material disadvantage through innovative application of advanced technology. Future submarine commanders would attempt to emulate Dealey's tactical excellence while adapting his methods to different circumstances and enemy forces. The strategic impact of USS Harder's patrol extended beyond immediate results. Japanese anti-submarine forces had been compelled to transfer substantial resources from other theaters to counter American submarine threats in the Southwest Pacific. Merchant shipping schedules had been disrupted by escort requirements that reduced Japanese logistics efficiency throughout the region. Most importantly, the engagement had demonstrated American submarine superiority in waters previously dominated by the Imperial Navy. Japanese naval doctrine would be modified to address tactical realities revealed through combat with aggressive American commanders who refused to accept defensive roles against superior enemy forces. Industrial engineering had proven decisive in determining combat outcomes. American submarine construction, weapon reliability, and crew training had achieved integration that enabled tactical excellence under extreme pressure. This systematic approach to warfare development would characterize American military operations throughout the remainder of World War II and beyond. The mathematics of naval warfare had been rewritten by men who understood that technical superiority required operational excellence to achieve strategic. USS Harder's crew had demonstrated this principle through actions that would be remembered as long as submarines patrolled the world's oceans in defense of freedom and democracy. Final analysis. The engagement between USS Harder and 4 Japanese destroyers represented more than tactical victory achieved through individual heroism. It demonstrated the culmination of American submarine development from defensive coastal patrol vessels to sophisticated weapon systems capable of strategic impact through systematic application of advanced technology. This transformation required integration of industrial capacity, technical innovation, and tactical excellence that challenged fundamental assumptions about naval warfare. Individual submarines could achieve decisive results against superior enemy forces through aggressive action, guided by scientific analysis of combat requirements and systematic exploitation of technological advantages. But such achievements demanded acceptance of casualty rates that reflected the mathematical reality of submarine warfare in contested waters. For every commander who achieved legendary status through tactical excellence, others died in depths where courage could not overcome mechanical failure or superior enemy response. The Pacific Ocean had become a laboratory for testing American military capabilities against determined opposition, The lessons learned through engagements like USS Harder's patrol would influence naval warfare doctrine for generations. Future submarine commanders would study these tactical innovations while adapting proven methods to changing technological and strategic circumstances. The principles of aggressive action, technical excellence, and systematic preparation would remain relevant as long as nations sought to project power through controlled use of oceanic space. American industrial capacity had proven capable of producing weapons systems that could achieve tactical excellence when operated by skilled crews, guided by innovative leadership. This integration of human skill and mechanical reliability would characterize American military success throughout World War II and establish foundations for subsequent strategic capabilities. The story of USS Harder and her crew represented the best of American values applied to warfare: technical innovation, individual initiative, systematic preparation, and courage under extreme pressure. Their sacrifice and achievement would be remembered as evidence that free societies could produce military forces capable of defeating totalitarian opposition through superior application of democratic principles to combat requirements. Can you imagine the pressure those men felt, knowing that their next decision could mean life or death for their entire crew? The courage required to maintain aggressive action against overwhelming odds reflects the finest traditions of American naval service, traditions that continue to inspire submariners patrolling the world's oceans today in defense of freedom. If this story of incredible courage and tactical brilliance has moved you, please subscribe to ensure you never miss these powerful accounts of the brave men who shaped our history. Share this video to honor the memory of Commander Dealey and the crew of USS Harder, heroes who demonstrated that excellence and determination can overcome any odds. Their sacrifice deserves to be remembered, and their tactical innovations continue to protect those who go down to the sea in ships in defense of liberty.